Hi, I'm Christian Kekriotis, and we'll be presenting on the steam engine. I'm first going to talk about the history of the steam engine. Um, so, the first steam engine was invented in 1689 by Thomas Savery, and it was originally used to remove water from coal mines. And this was a very rudimentary design, but it was improved in 1712 by Thomas Newcomen, who made some big advancements by adding in pistons. And the Newcomen engine was better because it wasn't limited to the pressure generated from the steam. So the pistons allowed the engine to generate a lot more force. The biggest revolution in the steam engine was by James Watt, and James Watt basically improved the steam engine by adding a separate condenser to the original design. The James Watt steam engine was used all over the place in trains and in ships. Um, and here are some pictures of modern day steam engines and turbines, and these new designs are able to make a lot more force and work a lot better.
Okay, so I'm Alessandro Leggio, and I'm going to talk about a little bit about the fundamentals of an engine, of the steam engine. So basically, the main function of a steam engine is to perform mechanical work using steam as its working fluid. Like we study other cycles of class using air as its working substance, or water as its working substance. The steam engine itself, the working substance is steam, and these engines are characterized as external combustion engines, and they're often analyzed using the Rankine cycle, which I have illustrated right here. And basically what happens is that the steam is heated using an external combustion, and once it's heated, the rise in pressure pushes steam out and causes mechanical work. So this is our selection. Basically, we chose to create a soda can steam engine. So here's some like the background of like the materials of what we use to implement into the soda can steam engine. So we have copper tubing right here. We also have a soda can. We chose an Arizona can, just something crazy. Aluminum foil. We have aluminum foil to like wrap around. Also a tea light candle, which is the main heat source, and an eraser uses a weighing tool. And all of these materials, like all of these materials can be found around the house. Like most of them we found around my apartment or the other people's apartment. And we bought the copper tubing at Ace Hardware, which was really close by. And yep.
Hello, Joshua Coker here. So the reason why we mainly chose this project was for the simplicity. As Alessandro just told you, most materials will be just found around the house and were purchased very cheap. And it was very quick and easy to put together. And the reason why we enjoyed picking this one specifically was like exposure of it. The engine is very open, and you can see how everything works, and none of the parts are covered, so you kind of get an idea. Coming back to what I was saying, reason why we chose it because of the exposure. You can see exactly how everything works and how you can see the steam becomes converted into mechanical energy and seeing the can rotate. And yeah.
So I'm gonna go into Alessandro again. So I'm gonna go a little bit into how exactly we constructed the steam can engine, and how we made it up. This is our finished product, not lit obviously. But basically what we did, we started by taking our aluminum can, or in this case the Arizona can, and using scissors or and a box cutter, we cut the aluminum can so it was about a height of 2.5 inches. And we also grabbed the butt end of a screwdriver and pushed out as you know, cans have a rounded bottom to keep stability. We mashed it so it'd be a stable and semi-flat base, so it could keep itself balanced and balance the candle on it too. So then what we did after is we took a hole puncher, a single hole puncher, and we punched holes on opposite sides of the can. What this did is that it created a hole, basically a slot for the coil to go in. Like I said, for the copper tubes. So externally, we took a copper tube, a very thin and malleable copper tube that we bought at Ace Hardware. I think it's about 1/8 of an inch, and we wrapped it. We took a marker and we wrapped it around like 2 or 3 times, so we could create a coil. And that coil was then it's straight, and then it had a coil. And what we did is that we took a plier and we bent the ends of it 90 degrees down so it'd be submerged in water, and then we bent them at opposite orientations, basically creating a jet. So when it was lit and the steam is pushing out, it will spin, which I'll explain later. Basically, after that, a weight was put on the bottom using an eraser, just a regular eraser, and it's aluminum foil to basically submerge the can enough in the water so it would, like the coils would be submerged in the water as well. Then we put a tea light candle, which is just a regular candle you can find at Publix, a small candle, and then we wrapped it in aluminum foil to keep its place in the center. And basically after that, the copper tube is slid through the can and positioned so that the coil is right above the wick. Alright, as you can see. Alright, so let's see how it performs. Basically, once constructed, the candle is then lit at the wick, and that's the thermal energy from that lit candle heats up the water in the coil, which we kind of like using it as a straw. We kind of like suck the water in so it stayed. There is water already in the coil once we lit the candle. So once that candle's lit, it heat up that water in the coil. That coil would eventually convert to steam, and that steam then shoots out because the steam builds in pressure as it's heating, and that steam will eventually shoot out of the copper tubes at the bottom, and because of they're in opposite orientations, it causes a rotation as shown in the picture right here. And yeah. Alright, so it physically, how to like quantify the efficiency in a physical sense. Basically, how you would theoretically calculate the efficiency, several measurements do have to be taken. Basically, since neither the pressure nor the temperature are constant in this engine, you can't use the first 3 assumptions. So basically, what you'd have to do is using a PV diagram, you can study the behavior of the pressure corresponding to the increase in the temperature, and yeah, basically due to the heating. And using the area of that curve of where you studied, you can calculate the work output of the engine. You can measure, which would be the top part of the efficiency, and you can measure the heat input of the engine by measuring by monitoring the temperature of the coil before it was heated and after it was heated. So you basically the gradient in temperature, you measure its heat energy from that. And that basically, if you divide the work output by the energy input, you're going to get the efficiency of the steam engine.
Steam engine has been around for a while, and it has been replaced by many other types, such as types of use for power, such as electricity, and combustion engines that use gasoline. But in today's time, we still use steam engine for multiple uses, such as heating, sterilization, where saturated steam is used as the heating source for process fluid heat exchangers, reboilers, reactors, combustion air preheaters, other types of transfer equipment. Propulsion, it's the driving force for steam turbines. For atomization, steam is used to mechanically separate fluids. Steam can be used to clean. It is used to clean out soup blowers that dislodges dry ash and slag and oil in coil boilers. Moisturization, when paper is being produced, steam is used so that the paper moving over rolls at really high speeds and it prevents it from tearing or having little breaks. And humidification, where steam is used to humidify air within an air duct before the air is distributed to other regions of a building.
So now that we have presented basically the background and how it works and the applications of a steam engine, we're gonna cut to the actual steam engine and how it works and all that.
So now I'm going to light the candle, which is going to be our power source of the steam engine. Alright, so we'll position this, and as you can see, it's starting to rotate as the water is evaporating into superheated vapor, causing a thrust it's gonna spin the can.